Hello, hi, and welcome back to my channel. In today's video, we are going to create this small project called Recipe Finder. The purpose of creating this particular project is to understand the MVI architectural pattern because we are going to use MVI instead of MVVM pattern. So let me give you a quick demo first, and then we will understand the basics of MVI, the advantage, disadvantage of it, and why we should use it with Jetpack Compose. What is the benefit of using MVI with Jetpack Compose? Okay. So as soon as we open this application, we will be getting a random recipe, the name, the image, the ingredients, and if you click on the down arrow, it will give you the instruction. Apart from that, if we search for a particular recipe, let's say something related to cheese, and if you search for it, it will go to the loading state and give you a result according to that. So you can see all the related recipes with cheese comes up. Okay. So we're going to use a public API for this called MailDB, and apart from that we are going to use MVI as I said earlier, and we will see how all these things work together. But first of all, let us first understand what is MVI, and then we will go to the actual coding part. Now let us understand the basics of MVI pattern first. So as you can see that MVI includes these three components that are model, view and intent, where model represents the app data and logic. View displays the UI components, that is, it is the UI layer, and intent basically handles the user actions, passes it to the view model for further processing. Okay, so this intent is a new component for this MVI pattern, and this is how the flow happens throughout the application. So the intent is passed to the view model, where the model is updated, and then the state is emitted, and finally the view is updated. For example, in general, there are generally three states in an application: a loading state, a success state, and a failure or an error state. Okay, so we handle these three states. Okay, so let's say when we are loading the application, we tell the UI that the current state is the loading state, and accordingly a certain component needs to be rendered. Okay, now let's say we have fetched the value and then we want to display the data. Now this is the success state. So we tell the view that the state is the success state, and therefore you have to render the component accordingly. And finally, if there is any error or failure in fetching the data or anything else, then we use the failure state, and the view handle the component accordingly. Okay. So these states are updated in the view model itself. The UI only uses this state to render the specific component accordingly. Okay. Next is the advantages of using MVI over MVVM. Okay. So the most important advantage of using MVI is the unidirectional flow. Okay, it makes the app to strictly follow the unidirectional flow. Okay, therefore it is easier for the data control in the UI. Next is the predictable state. As I state, if we divide the app into like smaller states or very simple states, then it is very easy to manage the entire application, especially if the app is very complex. Okay. The next is the handling these explicit user actions. So if we jot down the specific actions that the user will take, for example, in our case, the user will open the application and therefore we need to perform an action of loading a random recipe. So the loading random recipe is an action or an intent. And then let's say the user adds a query in the search field and presses the button. Now the intent of the user action has changed from random recipe to a searched recipe. So therefore we will tell the view model that we need to process an intent that is the search recipe intent, and therefore the view model will act accordingly and just simply return the state to the UI, where the UI will update the component accordingly. The next is testability. So since we are dividing the applications into states and actions, therefore it is simpler to write the unit test cases. Okay. Now, as I said earlier, that complex UI logic, predictable UI state, and testability are some of the features why or when we should use the MVI approach. Now coming to the disadvantages of MVI, there are a couple of disadvantages, but nothing so severe, I would say. So there is this learning curve that is required for creating this particular structure, as we have to maintain this intent and action sort of logic where we are passing the intent, getting the state back, and just handling the state. Okay, so we have to have that particular learning curve handled. Then there is some bit of boilerplate, I would say, because it is there with other applications also, with MVVM, with MVC. All the other applications are having some boilerplate similar to that. This is also having a bit of boilerplate and some sort of overhead also, because we are handling states, right? States, intents, these new things are introduced. Therefore, for any of the screens that is having predefined state to it, predictable state to it, like loading, success or failure, we have to add these states and intents to that particular screen also. So every screen would have these states and intents. Therefore, that increases a bit of overhead, but I would say that it is better for a complex application to have those. And finally, it can also introduce a bit of complexity to a large application if we are not handling the MVI pattern correctly. Okay. Now let us understand why we should use MVI with Jetpack Compose, as in what is the benefit of using MVI with Jetpack Compose. So Jetpack Compose is having this declarative UI, right? So that declarative UI aligns well with the MVI's unidirectional data flow. Next is the clear intent handling. So we all know that Compose is more of an event driven architecture, where we have this on click lambda being called, on press lambda being called, on swipe lambda being called. So we are doing this callback sort of events in most of the cases, in most of the components. Therefore, that suits well with the MVI's explicit intent representation. Okay. Next is the predictable state management. So as I said earlier, that MVI has this concept of handling states, okay, and Jetpack Compose has this concept of have composables. For example, let's say there is a screen, and inside that screen, depending upon a certain state, a certain composable needs to be rendered. Okay, so this particular pattern where the state is handled by rendering a certain composable accordingly suits very well with the MVI approach, as it is also having the concept of state. Therefore, depending upon the state, we can render the respective composable. And I already talked about testability, and I also talked about complex UI interaction, since MVI has, as I said earlier, MVI has this approach of intents and states. Therefore, it makes very simple for a complex application to be handled if we are doing it properly. And finally, it provides us with some learning opportunity to use this relatively newer pattern of architecture with the latest UI technologies. So now let's see how to use this MVI in our project, and we will create the recipe finder application. So I've created this new project called recipe finder application. Let us first of all structure the project. So I'm going to add a couple of packages to it. So the first one is data, and inside the data we would add another package called model, and we will also add another package inside the data, not the model, called network. Okay, now inside the UI we are going to add a couple of packages. First one is called screens. Despite we're having this one screen, I'm creating this folder. You can choose to structure your project accordingly. And after screens, we are going to add another package called components, and we are going to add one more package called view model. So this is the structure of the application we are going to create. Data, and inside data we are having this model network. Then we have this UI package and inside of this UI package we have components, screens, theme, and view model. Okay, so once we have structured the project, the first thing that we need to do is to add the dependencies. Let us do that. Open the build-gradle.kts, and we will add a couple of dependencies. So I've added these dependencies. The first three are for Ktor, because we're going to use Ktor to call the API and retrieve the data. The third one is for JSON, and the last one is for coil. Okay, and let us sync the project. So after the dependencies have been added and the project is synced, the next thing what we will do is we will go to the MailDB APIs homepage, and we will look for the respective APIs. This is the homepage of the MailDB API. and we will go to this API option, and we are going to use two of the APIs. The first one is the random meal API, and the second is the search meal by name API. So if I just copy this random API and open it, it will give you a random recipe every time you hit the API. So if I refresh it, you can see lamb biryani. If I refresh it again, it gives you tandoori chicken. So again, you will get random recipes every time. So what we need to do next is we need to create a data class with this JSON. So I will just simply copy this, open the project, and inside the data package we have this model package. I will do a right click new, and I'm going to use this plugin, that is Kotlin data class file from JSON. So using this plugin, we can simply paste the JSON and it will automatically convert it to a Kotlin data class. So I will simply paste the JSON that I copied, format it, go to advanced annotation, and I've made it as JSON. I selected the JSON for annotation, and we can give it any name. So I'm giving it as meal response generate, and as you can see, it generated two files. The first one is called meal response, the second is called meal. So we need to annotate this with serializable. Similarly, we need to annotate this also with serializable. Okay. So as you can see, it automatically has created both of these data classes. Now we can actually use these data classes in our UI and other places. So the next thing what we will do is we will add some files inside view model. Okay. So we will first of all create a file for handling the intents. Okay, so we will call this file as recipe view intent. It will be a sealed class. Okay. And I will add a couple of lines inside this. So I've added something. So I've added two intents. The first one is load random recipe, and the second one is search recipes. Search recipes takes in a query, and load random recipe doesn't take anything. Okay. That is why I have given it as an object. You can make it as data class also, but since you don't have anything to be passed, therefore you can use object here. Okay. So this particular seed class will refer to the intents. So in our case, we have two intents. The first intent is to load the random recipe. The second intent is to search for recipes. Okay. So the next file that we are going to create is for the states. Okay. So we are going to call it recipe view state, and it is also going to be a seed class. And inside this seed class, we are going to add a couple of lines. The first one is for the loading state, the second is for success, and the third is for error. Okay. Similarly, loading state doesn't require any parameters, therefore we can use object. And for success and error, we require certain parameters. For success, we require the recipes. So what would happen here is, let's say we have received the data and we want to update the state from loading to success. So we will pass this particular state, updated state, to the UI along with the recipes that we have fetched. Okay. And similarly, in case there is any error, we will pass the error state along with the respective message to the UI. Okay. So once we've added both of these, the next thing that we will add is the network layer. Okay. First we will add the network layer, then we are going to use that in the view model. So basically, by network layer I mean that we need to add the client, the API client, and the respective functions to call or hit both the APIs. Okay. So I'm going to call this file as meal API client. Okay. And inside this meal API client, what we're going to do is we're going to define an object called meal API client. So inside this meal API client, we're going to add the Ktor API client basically, which is basically using the CIO engine, and we're using content negotiation to pass JSON. Next, we're going to add both the functions. The first one for getting the random recipe, and the second for getting the search recipe. And just a quick note that I've added this as private because we're going to use API client here in this object itself. Okay. We're just going to refer to the functions at other places, and we're not going to use API client at other places. Okay, so the first function that we're going to add is called the get random recipe, where basically we're returning a list of meal. The first line here is representing the API URL. The second is for the response, where we are passing the URL to the get function, and we're requesting for the body and casting the response to the meal response data class that we have created earlier. And then finally we are returning the meals. Similar to this, the next one is the get search recipe, where we are passing query as the parameter, and we are similar to the first one, returning the list of meal. In this scenario, we are going to use the search API, which takes in a query parameter, and similar to the get random recipe, we are calling for the response and returning the meals. Now what we're going to do here is we're going to create a view model and going to use both these functions to handle the intents and update the state. Okay, let us see how to do that. So for doing that, inside the view model package, we are going to create a file called recipe view model, which will be a class. Now we are going to extend this recipe view model with view model, and inside the view model we are going to add a mutable state of the recipe view state that we have created earlier. Okay, so let me add that. So as you can see, I have added this mutable state of recipe view state, where the default value is recipe view state dot loading. So the default value for our UI state is the loading state. As soon as the app is called, the default state will be the loading state. Okay. The next thing what we want to do is to create a function for handling of a processing the intent. So we'll call this as process intent, and I'm passing the intent to it. So what this will do basically here is that the UI just needs to pass the intent, okay, and the respective functions that needs to be triggered for those intents will be handled by the view model itself. So in this case, what we are doing here is that we have created this function which takes in the recipe view intent, and when the intent is the load random recipe intent, we are going to call this function that is load random recipe, and when the intent is search recipes, we are going to call this function that is search recipe. Okay, and we're going to pass the query. Now let us create these two functions. Again, these two functions will be private to view model, because as I said earlier that the UI just needs to be concerned about the intents, nothing else. Okay, so let us create both of these functions. So the first function is called load random recipe. Okay, now inside the load random recipe, what we're doing here is we have added this view model scope, and we are updating the state, the initial state, to a loading state, and inside the try block we are again updating it to a success state if there is no errors, and inside the success we need to pass the list of recipes, right? And we will get this list of recipes by calling the get random recipe, because this function is called when the load random recipe intent is requested by the UI. Okay, in case there is some error, we will update the state to the error state, and we will pass the error text as error fetching recipe. Okay. Next we will create the search recipe function. So inside this, it is similar to the first one itself. The difference being here is that instead of calling the get random recipe, we are calling get search recipe, and we are passing the query that is passed to the search recipe by the intent. Now after writing this, the entire view model is completed. So what we have done here is we have defined a state that is basically is the mutable state of the recipe view state, where the default state is the loading state. Then we have defined this function which is used for processing the intent, which basically takes the recipe view intent, and depending upon the load random recipe intent or search recipes intent, it calls either load random recipe function or search recipe function. In case of load random recipe, it first makes the state to loading, and in case it is successful, it will change it to a success state, and it will pass the list of recipes by calling the get random recipe. And in case of error, it will just simply update the state to the error state, and it will add the error message to error fetching recipe. Similar to this, we have the search recipe where we are passing the query string. Similar to the random recipe function, we are updating the initial state to the loading state, and in case it goes inside the try block, we are updating the state to the success state, and we are passing the list of meals by calling the get search recipe and passing the query parameter. And in case there is some error, we are just updating the state to the error state, and we are passing the error fetching recipes error message. Okay. Now the final thing that is left here is to actually create the UI, and the UI is going to be pretty simple, as you must have seen in the demo. So let us do that. Now for creating the UI, we will first go to the main activity, and we will remove all these things. We don't require all these composables. And what we are going to do here is to add the or initialize the view model that we have created. So we will call it as recipe view model. The model by view models. Okay. The next thing what we are going to do is we are going to create a composable inside the screens package, and we are going to call it as home screen. I will just simply create as composable home screen, which takes in the recipe view model as the parameter. Okay. Now we'll go back to the main activity, and we'll just simply call the home screen, and we will pass the recipe view model. So that is pretty much it for the main activity part. We don't need to add anything in the main activity now. Let us go to the home screen, and inside the home screen we're going to add a couple of things. Basically we need to handle the UI according to the state changes. Okay, so this is how we will do that. So what I have done here is that I have used this variable called state, which is basically holding the recipe view state from the view model, and depending upon the state changes we are going to call different UI composables or UI components. And so in case of loading state we are going to call loading component, in case of success state we are going to call success component, and in case of error state we are going to call error component. Now let us simply create these three components. Okay, let us create the loading component first. So inside the components package, I'm going to add a new file called loading component, and which is pretty straightforward, nothing special here, and we're just going to display a text called loading. So this is how I'm doing it. I've added just this column with fill max size as the modifier, vertical alignment as center, alignment horizontal alignment as center horizontal, and I've just added this text loading. Okay. So as you can see, loading component has been added. So the next is the crucial state, that is the success state. So inside the success state, what we are going to do first is we are going to get the recipes. Okay. So we have the state over here, and we know that the success state returns or holds the recipes with it. So what we're going to do here is we are going to cast the state as recipe view state.success, and we're going to call .recipes. Okay. Now we're going to pass this recipes to the success component. Let us create that. Okay. Once we have added that, what we're going to do inside the success component is we're going to create the UI. So the UI has two components mainly. The first one is the search component for adding the search text field, and the second is the card or list of cards, right? So the next thing apart from the recipes parameter that we need to add is one more parameter called on search click, which should have a parameter of its own of query. Okay. And inside the success component, there will be mainly three components. The first one would be just the name of the application, that is recipe finder, and the next two would be the search component and a meals list component. Okay, let us add that. So as I said, as you can see, I've added this column composable and I've added this text inside this, where I've added the name, the font weight, the family, the font size, and the modifier, that is this padding of 80p. And I've added two more components called search component and recipes list. So search component would basically handle the text field where we are going to add the search query, and the recipes list would basically display the list of cards of recipes. Okay. Let us now create the search component. Okay. Let me add a search component. Composable function search component, and it takes on search with query string unit. So inside the search component, we're going to add a couple of mutable states. So this first one is for handling the state of the query. The second one is for handling the error message. Okay. In case there is some error handling for the text field, we need to use error message for that. Now after that, we are going to just simply add the column and an outline text field. So here it is how I'm doing it. So what I am doing here is that I've added this column. I've added this column and I added this modifier fill max width with padding of horizontal 8 dp. And then for the outline text field, I have added the modifier as fill max width with background as white, and for the value, the query, this particular query. And on value change, what I'm doing here is that in case the value that is changed is not blank, I am updating the error message to empty. For example, let's say the user clicks the search icon without adding any query, it would display a message, and as soon as we start typing something inside the text field, the error message shouldn't be there anymore. So for removing the error message, I've added this particular logic, and also I'm updating the query with the on value changed value. The label is a search text, single line true. If it is an error, I'm just using this as the logic for doing that. And for the trailing icon, I'm adding an icon button. And what I'm doing here is that in case it is not empty, I'm calling the on search click and passing the query. And in case it is empty, I'm updating the error message with enter query first. And finally, I'm using an icon over here. And after that, what we will do here is we will add the error message text. So in case the error message is not blank, and that means that there is an error message, we are going to display the error message. We are going to use the error color for that and label small as the style for the text, and a padding of, let's say, not 16. You can use anything you want, it's totally up to you actually. So if you want to change this, it's totally up to you. Okay, now as you can see, I'm getting this error, right, that this is experimental and all those things. So in case you want to handle this, what you have to do for this is you have to go to build.kts, and you will see this implementation of material 3. We're going to add the latest version, which is 1.1.0, if I am correct. Oh, it's 1.1.1, my bad. And you will have to sync this. So as soon as you sync this, that error that you're getting for the text field and all, that shouldn't be there anymore. So if I go back to the success component, search component, as you can see, the error is gone. Okay. So I've added the column, I've added the outline text field, we have handled the updation of query and the error message, and we are also adding the icon button and using the search icon. And on clicking the icon button, we are calling this on search click and passing the query in case the query is not empty. And in case it is empty, we are calling this error message. And in case the error message is not empty, we are displaying the error message text. So once the search component is completed, the next thing that is left is the recipes list component. Okay, let us create that too. We go to the components package, add this as a new file, create a composable, add recipes list of meal as the parameter. Okay, And inside this, I'm just simply going to add a lazy column with another composable inside that called recipe list item. Okay, something like this. And for items, we are going to use this particular import. Okay. Now what I'm doing here is very simple. I'm just using a lazy column where I'm adding the modifier for fill max size and background for color white. And I've added the items for recipes, and I'm just iterating or creating the lazy column using the recipe list item. Okay. So this is basically the component that is going to create the specific or individual cards. So now let us do that. Let us create the recipe list item composable. Again, inside the components package, I'm going to create another file called recipe list item, and I will use the composable annotation, add the function recipe list item. This will be just a meal, and inside this, what I'm going to do is I'm going to add one more state called expanded. So this is basically going to handle the expansion and non-expansion state of the card. So in case the card is not expanded, it will just display the name and the ingredients, and if we are going to expand the card, it will display the instructions also. Okay. Now after adding the mutable state for handling the expansion of the card, let us add the card and the contents as well. We will add this entire block of code. So what I am doing here is I've added a card with modifier as fill max width with padding of 8 and shape as rounded corner shape as 4 dp, and I've added a border stroke of 1 dp with the border color as light gray, and I've given the background color as white. Now inside the card, the actual content is basically a column composable, and inside that, now inside the column, what we're doing here is we are checking if the str meal thumbnail is not null or empty. We are calling the coil composable, and we are displaying the or passing the value for the thumbnail to it. We are using the content scale as crop, modifier for it as fill max width with height as 200 dp, and we're going to clip the corners to the shape of rounded corner shape with 8 dp. I've added some space, then a text for the actual name of the meal. For that we are using str meal, font size as 24 sp and font weight as bold. After that we have also added a space, then again a text for ingredients with 20 sp as the font size and font weight as semi-bold, and then we are going to display the ingredients. Okay, now for displaying the ingredients, I'm going to call a function which basically gives us the format in which we want to display the ingredients text, because if we go to the meal data class, you will see here that the individual ingredients are stored in different fields. So we have str ingredient 1 up till 20, and similar to this, like the respective measurement for each of these ingredient is stored in the str measure 1 variable. So if the, let's say if the ingredient is sugar, that is going to be 1.5 tablespoon. The sugar, that particular value is going to be stored inside str ingredient 1, and the measurement for that is going to be stored inside str measure 1. It is a bit weird, the format in which they are added. So what we can do is we can create a function which basically handles all these ingredients and their measurements, and then just simply return a string that we can display. Okay, let us do that. So what we will do at the very bottom here is we are going to create a function called get ingredients, which takes in meal and returns a string. What I'm doing here is basically I'm just checking if the ingredient 1 is not null or empty. If it is not null or empty, it means that we can just simply add this particular string to ingredients variable. Similarly for all the others, and at the end what I'm doing here is I'm returning the ingredients string and I'm returning the end. If you go back, this is where we are going to use this function to display the ingredients, and then again I've added some space. Now inside, after this, what we're going to do is we are going to hide all the instructions. Okay, so how to handle this smoothly is to use animated visibility composable. So this is a composable which is going to handle the visibility and invisibility of a component inside it. So we can just simply write animated visibility, and we can pass the visible value by passing the expanded mutable state. So in case it is true, it will display this. In case it is not true, it won't display it. And it will handle the animation of displaying and not displaying, or basically hiding and showing very smoothly. So inside the animated visibility, we are just going to display the instructions along with the header as instructions. So we are going to add a column composable, then we are going to add a header of instructions, semi-bold and font size as 20 sp, and just the instructions. And at the very bottom, we are going to add a down arrow, such that if we click on the arrow, it would expand the card, and if we again click on the arrow, it would shrink the card. So this is how I'm doing that. So I have added a column which takes in the max width, and for the clickable, it is just updating the expanded value. And for the icon, I'm just doing this logic where if in case it is expanded, I'm going to use the up arrow keyboard icon, and in case it is not expanded, I'm going to use the keyboard arrow down. Okay, tint as black, modifier alignment as center horizontally. Okay. So to reiterate, what we have done here is we have added a card. Inside the card, we have added the async image, which is basically using coil to display the thumbnail. After that, we have added the meme name. We have added the ingredients. We have used this function to format the ingredients accordingly. Then we have added this animated visibility to display the instructions once the icon is clicked. And if we again click the icon, it would hide the instructions. Okay. Now the last thing that is left is the error component. So let us handle that. Let us simply add the error component. Which takes in message string on refresh click. And what we're going to do inside this is very simple. We're just going to display a text and a button. Okay. So we are going to display the message that is passed, and we are going to create a button with text refresh. And upon clicking that, we will just call this on refresh click lambda function. So the purpose of clicking this refresh is, let's say we queried for something for which there is no value, okay, or let's say we get some error of any sort. So what we want to do is we want to go back to the previous state. The previous state is basically to again generate a random recipe. So to handle that, to again generate the random recipe, we are going to use this lambda. Now inside the home screen, the last thing that is left is to call the launch effect block. Now what will happen here is that as soon as the home screen is rendered, this block will be triggered, and we will call the process intent function in the recipe view model, and we will pass the intent for getting the load random recipe. So if we go to the process intent, what will happen here is that it will look for this particular case, and it will call the load random recipe function, and this will be triggered. And in case it is successful, it will update the state to success, and it will fetch the value for it from get random recipe function from the mail API client. And if we go back to the home screen, now what will happen here is that since the state is updated, again this block will be triggered, and it will go to this particular block. Since now the state is success, it will get the recipes, and it will pass the recipes to the success component. Now to make it more readable, what we can do here is that we can just write on search click, and instead of writing it over here, we can write it inside this. Now let's say we have added some search component, and we have written the query for it, and we have clicked the search icon. In that scenario, as soon as we click on the search icon, this particular block will be triggered, this entire thing. Now the intent is changed from load random recipe to search recipes. So again, we will call this particular function, that is process intent, and we will pass the search recipes intent for it along with the query. Again, it will go to the process intent function. It will go to this particular case. It will call this particular function, that is search recipe. And if it is a success, it will call the it will call the get search recipe, and it will get back the list of meals. And again, the state will be updated to success. We will get the recipes, and we will pass the recipes to the success component. In case there is a scenario that we are getting some error, we will call the error component. We will pass the message that we receive from the updated state. And again, to make it more readable, we can simply write on refresh click, and instead of calling it over here, we can just call it inside this. Now what will happen here is that, let's say we are getting the error component on the error. Now let's say we are getting the error component on the screen, and if we click on the button to refresh, this will be called and this entire block will be triggered, and again we will process the intent for load random recipe, and therefore it will again load a random recipe and therefore process the UI accordingly. Now let's run the application and check first of all if everything is fine or if we have missed something. Let us do that. So one thing that we missed was actually adding the plugin. So we need to add the serialization plugin and sync it, and then run the application. Otherwise you will get an error saying that the data class needs to be serialized even though we have added the annotation, but it won't work since we didn't add the plugin for it. So once you've added that, let us again run the application and check. So as we can see, we are getting the loading state and then we are getting the success state. So the random API is working fine. We are getting the success state, we are getting the recipe for this Kentucky Fried Chicken, and if you click on the down arrow, we are getting the instruction as well as the animation for this showing of the text and even for the hiding of the text. Now let us simply search for something. Let us search for cheese, and if we click on this, we are getting the respective recipes related to cheese. And in case we add nothing and click on this, you will get this error which says enter a query first. And if we add, let's say, tomato, and if we search, you can see it is giving the value. Now let us add something gibberish to it, and again search. It will give an error because there is nothing for that particular query. And if you click on refresh, it would again load the random recipe from the random recipe API. So this is pretty much it. We have created this particular recipe finder application in this very short time, and I also hope that you all have understood the concept of MVI pattern. And if you have any queries regarding this, and if you have any questions, feel free to reach out to me. Do write your queries in the comment section below. And if you have stayed till the end, please like the video and share this video if you have found this useful, and subscribe the channel. And I will see you in the next one.